Research objectives for the final project. Let me ask y'all what y'all think somebody, looking at the questionnaire, what y'all think would be some of the research objectives here? We'll be trying to find out if people can afford to pay tuition as it is now. Yes? Alright, so when I got a questionnaire in front of me now, the first thing would be, is the current tuition system affordable? We're hearing a lot of things in the press. We're hearing all things, but based on what the students say, can the majority of people afford it or not afford it? Now let me ask you a question. When you are writing this report, you'll be writing it for several stakeholders. Who are some of these stakeholders? Who gonna want to know the answers to these questions? Huh? University administration. So when you are writing up the recommendations and you are discussing the findings, you are not discussing them for me or for you. You will be speaking to the university administration. Who else? Financial institutions. What they need to know for? Just to go by calling programs and confuse the place? Anybody else? You mean sponsors? Yes. And you must certainly be speaking to the Barbadian government. Alright, so there are lots of stakeholders for these questions. And when you will report the findings, but then when you are doing your discussions and things, you should be speaking to these stakeholders. I can't, that's the part you got to do for yourself. I got to see how creative you get with that. And if you could see which questions will speak to who. Right, Mr. Giddens? So there are some questions that will look at whether the current tuition system is affordable. What are some of the questions? Look through and see. You got to look through and see. The first thing you will do with this questionnaire is run frequencies and percentages for all the nominal questions and means and standard deviations for all the ones that are interval, right? That is the first thing you're going to do. That can give you a sense, run through that data, look at it, see what's going on. Some of those questions will tell you about whether the current tuition system is affordable. I could think about one question off the bat. Questions like what? Yes, if you apply for government bursary, if you apply for government bursary, chances are you needed the help. But I got some people that would have said, well, my father is a permanent secretary, so he's going to get one. All right, so that may or may not, that will give you a sense. So what I'm saying is that there are several questions you could probably put together to get a picture. There's another question I see in there that will tell you a lot. Look through, that will tell you whether it's affordable or not. I think 7 is a good question. How difficult was it? You have them? Who are the thieves? Let me shoot them. That's all right, only kidding. It's just that I didn't want the stress of doing it today, that's true. Because I get enough run wrong with them. I had to give you all the first set in a half because all the printers are breaking down. Yeah. 7 looked like a good question. How difficult was it? All right, but I ain't itemizing the questions to you. I just showing you the research objectives. All right, so is the current tuition system affordable? Several questions may answer this for you, and who then will be the stakeholders? You will have to decide who's the stakeholder. Any other questions? Any other research objectives? You may want to profile the current funding options. Where did folks get the money from this semester? You might want to profile that. I won't tell the test to do that. Why would I want to do that, though? Why would I want to profile the current funding options? Why would I want to know, like, how much persons chose X, how much persons chose Y? What's that? Yes, it could, but think about it like a marketer. Huh? Why Gibson? Why would I want to know that? Why would I want to know how students are ranking funding options right now? Oh? Where? Were you going to offer them? I am, for example, a credit union, right? We would want to know how much of them want to choose the credit union, because if ain't none of them, what I would tell you? That you got to do what? Thank you. That is strictly a marketing question there for the financial institutions. Oh, everybody's looking to write it down now. You got to think. All right? So we want to profile the current funding options because that is marketing. You want to tell them what is most feasible to students and how you may need to make your offering more attractive. Any other research objectives? Can we think of anything else we're trying to find out here? Huh? Yes, you can look at, for example, future behavior of students, what they think they're going to be able to do. And you also have to look at maybe future funding options, where they intend to focus. This once again is a marketing question. Why are they looking in particular directions and not at particular directions? So the future behavior of students, who would they speak to? What the students are saying they may or may not be able to do. Future behavior of students, she's talking about the fact that they may not continue or whatever. We need to speak to UV with that. Future funding options, that's marketing again. And a lot of the questionnaire is about what? Quality of life right now, financial stress, and overall stress. The quality of life, the financial stress, the overall stress. Who do we need to talk to about those findings? Who's the stakeholder there? The level of the quality of life students having now, the financial stress and overall stress. UE specifically, which section of UE? Correct. You see you done get 10 out of 10, and they don't even give 10 for this class. You done get 5 out of 4 for participation, Ms. Matthews. I'm telling you. Student services. All right? What are we going to tell student services about? Because that will tell you what is necessary and what may be needful right now in helping students. Now, work here with me. We could do all the percentages and means and standard deviations, but we could also look at some relationships. For example, is there a relationship between, I don't know, quality of life right now, how you feel about your life and your age, or your income, or your gender, or whether you're part-time or full-time, or whether you're employed? Is there a relationship between your overall stress level and your difficulty in finding funding, your income, your age, your gender? Because it will tell me, it will help student service to know which segments of the population they need to zero in on that may be having psychological trouble. All right? So when you get down into those types of questions there, you might also cross things like future behavior of students with all the demographics. Is it the men who saying they're going to leave? If there's somebody going to leave, is it the women who saying? Is it the younger people, the old, who wants to leave if there's somebody who is not sure that they can continue? All right. You might also look at who believes the current tuition system is affordable. So there's a room to look at these questions on their own, and then there's room to cross them and to look to see if there are any significant differences. You might not. You might find everybody feels the same way. Then you just go right back up to the original percentage or mean. If they're different, then you can show student services or the university or the government where the differences exist. Now there's something I want to show you. Now, there's some multiple item scales on this questionnaire. If you do not want to go as deep as to study them, I don't mind, because I'm actually collecting that data for myself because I want to study them. Right? I want to study them. Now, if you look on, say, page 5, you see I got a scale here with 14 questions. So I got a scale here with 14 questions. In the last month, how often have you been upset? I think it's Nels and them that presented this scale to me. the perceived stress scale, how much stress you perceive you're having. We have 14 questions here. So this is like a multiple item scale. It's a multiple item scale. You could go as far with this as you want. There's several multiple item scales here. There's the one here about stress. There's the quality of life scale. That is 5 questions. In most ways, my life is close to ideal. The conditions of my life are excellent, and all those. That's another multiple item scale measuring quality of life. There is a third multiple item scale on page 6, which measures what we call financial stress. Not having enough money for emergencies, living paycheck to paycheck, barely having enough. And then there's a final scale on page 7, which talks about what thinking about tuition fees may be doing to you, noticeably affecting my stress level, affecting my ability to sleep, making it more difficult to concentrate, making me more anxious. This is actually a scale that I'm trying out to see when I run the reliability analysis on it, if it looks good. Now, I am not going to penalize you if you do not use these multiple item scales. I'm not going to do that. And if you just pick out one item, and then you do your analysis on that one item, it is fine. But I just want to show you how we use multiple item scales. You see this multiple item scale here, for example, quality of life. In most ways, my life is close to ideal. The conditions of my life are excellent. I'm satisfied with life. So far, I've got the important things I want. If I could live my life over, I would change almost nothing. You can actually put in the data for each and every one of these, and then turn around and swoop them up and make them one question. So what you would actually be doing is looking at how the person responds to all of these in total. All right? Does anybody have SPSS up? Call up SPSS. Let me show you how you just do that. Go to the data set 3. Go to the data set 3. And I can show you how you just do that. How you will make them all one question. Are y'all following me here at the back? Go to data set 3, and I can show you how you will make them all one question. I'll give you a minute to get there. So if you decide you just want to pick up one of these items and assess that, no problem. If you want to swoop them up together into one scale, which I am going to do when I get my hands on the data, let me show you how you do that, because sometimes if you have a multiple item scale, you need to know how the person rates across all of them, not just one. You all right? You just had enough. All right, in this data set, right, you see we have 4 satisfaction questions there. We could assume that all of them, those are measuring different satisfactions. Those are not on the same scale. But we could assume that those satisfaction questions are just like these, all of them measuring the same thing, quality of life. These are redundant. You know we had talked about redundancy in questions? There's redundancy in here. So we could assume that all 4 of these satisfaction questions are measuring quality of life. How do you make them one? You have to transform those 4 questions into one. Do you see something at the top marked transform? You see something at the top of the screen marked transform? Click transform. Write that down. Transform. That's how you can take all of the items in a multiple item scale and make them one. Click transform. So we're assuming we're taking all of the items and making them one. All right, so transform. And then you want to compute a new variable. So click compute variable. All right. Now, you see over there, target variable. What name you will call this overall variable? Call it quality. Because it's all of them you're putting together. So type in quality. If we come right to the If we come right to the right, you see something there about function group? Click all. Click all, write that down. And you can either sum up these variables, watch me, or you can calculate a mean. In other words, if I was looking at Shanice's score, nulls, I'd be looking at if she had given, in most ways, my life is close to ideal of 4, and then she had given the conditions of my life are excellent of 5, and she had given I'm satisfied with life of 3, and she had given I've gotten the important things in life of 4, and maybe if I could, I would change almost nothing to 5. The system can sum up all of these. 4 and 5 is 9, and 3 is 12, and 4 is 16, and 5 is what? 21, and that could be Shanice's score. So if you ask the system to give you a sum, it will now create a new target variable, and for every person, they will create a sum of their quality of life. Or you could ask the system to do a mean or an average. So it would have added up all of these, and then it would have divided it by the 5, which is, well, 521 is 4 point, well, I know 2, and it would have then created an average score for Shanice, and it would do that for every single person. It would create a new variable. You have that? So you understand the logic behind it now? It will calculate a mean or an average. Up to you. So when we click all here, you get what I'm saying? So I'm swooping up everything you are saying on all of those variables, because I'm assuming that all of them are measuring basically the same thing, which is quality of life. You look puzzled, Gail? You look puzzled? Huh? Oh, good. All right. So when we click all here at the right, we seeing all these functions now on the bottom of it. Come down now to functions and special variables. And as we come down, wait, what should we gone? Mr. King, what you tell me pass it? As we coming down, you seeing a mean? You seeing something about a mean? You see a mean? So you look first, you click all, and then you come down to the second box beneath that with functions and special variables, and you see a mean, right? You got that? Click mean. All right? What comes in there? You see stuff come in the box next to it? Send it up. Click the arrow, and that sends it up. Send up the mean. So you go from function group to functions and special variables, identify the variable. It describes what it is for you, and the arrow just above the long description, send it up there. Where does it go? It goes up to the top, right? Right. So it is going to allow you now, you got to remain in between the two brackets, and you must have a comma between every item. So it allows you now to send over the satisfaction questions to calculate a mean. So come over to the left now and click how satisfied are you with our customer service. Click on that. Is everybody following me? I now want to calculate a mean of the variables that will be inside those two brackets. So I got to get them. I can't get rid of the brackets at all. You know about functions, right? I'm calculating a mean on what I put inside those two brackets. So click now, how satisfied are you with our customer service? You're there with me? And send it across. When you send it across, you have to have a comma right after it. So skip past the comma, because it's like this. If it was sum, it could be sum if you were adding, or I mean sum. The bracket, satisfied 1, comma, satisfied 2, comma, satisfied 3, comma, satisfied 4, no comma, close the bracket. If it don't look like this, it is not going to compute. Right? So when you click them over and make sure they got commas. No spaces in between here neither. No spaces. Alright? So you try not to do that for me. Click them over each and make sure there's a comma in between them, and they got brackets on both sides. If the brackets move, look on your keyboard and put it back in. All right, because the expression, whatever you're doing, must be in between those two brackets, and you have to have the commas. And when you are there, then I will tell you what to do again. Take out the question mark. Because the question mark was there to tell you, well, what you're putting in there. What you're asking about. Take out the question mark. Question mark got to come out. Y'all following? All right, let me try it now. Let me see if it works. Click OK. All right, look at the variable view. Look at the variable view. Click OK. Look at the variable view. What you got there now? You got a new variable named quality. You got a new variable named quality? Yeah. Click on the data view now. Click on data view. Click on data view. You're upon the data view, darling. There. Right? And come down. Everybody knows you got. Go down so. Go to the end. Go to the end. So got an extra variable there now. And that is their mean across all of those satisfaction questions. So that would be your mean across the quality question. Yes? There's just one more thing I want to teach you. There's just one more thing I want to teach you. And it is this. And a lot of people do SPSS and they never learn this. But you need to know it. Yeah? If we look back on page 5, Mr. King, let me get close to you because I took your question here. If we look back on page 5, these questions are measuring perceived stress. They're measuring perceived stress, right? And start by reading the first one. In last month, how often have you been upset because of something that happened unexpectedly? In the last month, how often have you felt that you were unable to control the important things in life? In the last month, how often have you felt nervous and stressed? Look at question 4, though. Look at what question 4 says. In the last month, how often have you dealt successfully with life's irritating hassles? What's happening here? What's happening here is that the first 3 questions are positively worded, negatively worded. How often have you been upset? How often were you unable to control? How often have you felt nervous and stressed? Look at the 4th question. How often have you dealt what? Successfully. Folks, if you try to swoop up all of these questions together in the same way that you did, it will make sense because this is a question that is now asking the question in a positive way. So go through for me and identify the questions that are not negative. And I can show you what you have to do with them before you do this. Go through for me the 14 questions and identify the questions that are not negative. This is the only scale in this questionnaire that has both negative and positively worded items. Why we do it like that? We want to be sure that the person is reading. Because if the person says very often for a positive question, they should say never for a negative one. If they're saying very often for a negative one, they're not being reliable. So oftentimes when we have these multiple item scales, we throw in some questions that are worded the other way. Y'all understanding me? See the trick? So go through for me and identify the questions that are positively worded. Because it's a negative scale. It's a scale about stress, which is negative. But find the positively worded questions for me. How much positively worded questions? This to be sure that you're answering reliably. Because the redundancy, you'll be turning in the other direction. If you say positive, you shouldn't be saying positive for all. You should, if you are already stressed, on the positive questions, you should be on the opposite side of the scale as if they're negative questions. How much of them we all find? You find 4? I find 7. You got to turn over. They're 14. So for me, the positively worded questions are 4, 5, 6, 7, 9, 10, and 13. So work here with me. If for question 1, you put very often, in the last month, how often have you been upset because of something that happened unexpectedly? If for question 1, you put very often, what should you really be putting for question 4? Never. You should be putting never, right? here. The issue is recording the scale. Because listen. Don't want to put you wrong. If in the last month how often you've been upset because of something that happened unexpectedly is a very often, right? You have that? There's a very often. You should be saying what if you are talking about how often you have dealt successfully with life irritating stresses. Where should we be going? Never. These are supposed to be measuring the same scale. So then something would be wrong with the scale, isn't it? We have a set of negatively and positively worded questions here. Right? So all of the questions should really be what? All should be what? Negatively worded. Or all should be what? Positively worded. That's fine. You don't need to record this scale. I've taught that through. It's fine. All you need to do with this scale, woohoo, is just what I did before. No, this doesn't need a record. Because you know what? This is frequency of times. This is not agreement. Yeah, I'm sorry. Sometimes I just got to think through things. All you need to do with this is soup it up. Because if I'm saying in the last month I've been upset and very often, and then I say in the last month I have dealt successfully and I put never, no, that's fine. I don't need to record this scale. So all you need to do is swoop these up the same way you swooped up quality of life. So I am leaving it up to you whether you want to just pick up one of these questions and focus on, or whether you want to swoop them all up and create new variables. All right, I'm not going to penalize you if you don't swoop them all up. Because even if you look at page 7, you see that first question, thinking about paying tuition fees is noticeably affecting my stress level? That question that is actually a general question I put in there. All the other questions break that down. All the other questions break that down. Like, what could affect your stress level? Ability to sleep. If you're stressed, poor ability to sleep, can't concentrate, more anxious, more panic, more worry about money, all those things are elements of a stress level. So for that particular scale, if you just focus on noticeably affecting my stress level and you only focus on that question, that'll be fine. You get me? Because that, for me, is the general question. I put that there, but I'm going to assess that by itself. I'm not going to include that in my scale because that is a one-item, stand-alone question. I am going to swoop up all the rest. All right? But for you, you can just focus on noticeably affecting my stress level. All right? And do your analysis with that one question. You can pick out the individual questions with the financial scale on 6, not having enough money for emergencies, living paycheck to paycheck. You can pick out the ones that you want there. All right? But for the quality of life, attempt to swoop those up into one. The 5 quality of life questions. And for these questions, the scales, the perceive scale, you can swoop those as well. And the one with 7, you can just assess noticeably affecting my stress level. Because really and truthfully, this data is for you, but it's also for me. When I take all of your data together, then I will do my analysis. All right? Or positively, they have to be recorded. I haven't done that for a while, so I need to look back at how I do that. And I will tell you. All right? So what's wrong, Hall? I'm supposed to know everything? Huh? So you expect me to get here and lie and say you know everything? I'm not going to do that. That is not Christian. That is question 5. Question on page 5. The long question with all those different things. I do need to record the positively worded questions. So collect your data and don't worry. When I go and read it over, I'll know it in a minute, and I will explain it to you. All right? All right, so let's go back now to our data set 3. Let me ask if there are any other questions about the project before we move on to data set 3 again. So you understand how to make all the variables 1, right? Hold on. When I show you how to record the variables that are positively worded, after you have done the record, hold on. Let me show you something before I leave here. Where you would have had satisfaction 1, satisfaction 2, satisfaction 3, satisfaction 4, you would have stressed 1, all right, stressed 2, okay, stressed 3, but you know what you would have to put in here? The recorded. Wherever you have a question that is worded in the other direction, you have to create a new variable for each and every one. So for the 7 questions that are coded in the other direction, you have to create 7 new variables. Hold on. And when you are swooping them all up together, you will put in these questions that are negatively worded as per usual, but then you will put in the recorded version for the 7 questions that were positively worded. Y'all understand that? So all of them would be then negatively worded. Yes. Do you get that? Or don't you at the back? Y'all at lost. That's the thing. That's why I can't remember. So I need to, Look, let me fiddle around with it, because I've done this many times. Let me see if I could figure it out. Give me a minute. All right, I trying it out, but I ain't remembering right now. And I didn't even remember that I didn't remember, so I could have remembered to check it up to tell you the truth. I remember that I remember. All right, so let me check my old book, my friend Andy Field, and he will remind me in a minute, and I'll tell you when we come again. But you understand my logic. If some of the questions are worded in a different way, if when you are giving me a 4 on this question, and 4, 4, 4, but then you give me a 1, that 1 is going to offset the average. Y'all get what I'm saying? Because the question is worded in the other direction. So I have to bring the question over. So if we look here, for example, where I could at least explain the logic to you, where I have very often, fairly often, sometimes, almost never, never. And if I'm going along with all these questions very often, then I might end up with an N over here when the question is now positively worded. So that will offset my average, because it really is not a 1, it is a 4. So 1s have to become 4s, and no, there's a 0. 0 have to become 4s, and 1s have to become 3s, and 2s remain, because this is the midpoint of the scale. All right, so I have to get over the 1s to 3s and the 0s to 4. Y'all get what I'm saying? Right? So that is what I need to go and check and find out how to tell you what to do. Huh? Okay, all right. Can't remember the thing now. So let's go back to data set 3. You're at data set 3? All right, we're back at data set 3. We're back at data set 3. Good. Can anybody remember when to use an independent samples t-test? When to use an independent, we're just going to recap before we move on. When you have, you're crossing, where are the 2 variables you're crossing? A nominal by a interval. And you do the independent samples t-test when? When the nominal has 2 variables. Now, you can check back to SPSS and look at the commands. Okay? No problem. Did you write down which box to look in? My SPSS handout shows you that. Which box to look in, etc. When do you run an ANOVA? When you have more than 2 variables in the nominal. All right? Look back now at the SPSS handout. And let's just go over again which boxes we look in. Okay? For the ANOVA, you look in the first box for the P. If you get a p-value of 0.05 or less, what does that tell you? It tells you that there's a statistically significant difference between the means of the 3 groups or the 4 groups. But the problem with ANOVA is that there may be a statistically significant difference between mean A and mean B, but not mean C, whatever. So when you look in which box tells you which of the elements have different means. Box 2. Box 2 tells you where the significant differences in the means are. All right, if you look here. And then when we look in the third table, we will actually see the means. All right, so when you look in box 2, all right, you will see which means are different. And then when you look in box 3, you will actually see the means. And the same principle holds in box 2 as held in box 1. You look to see under the significance and you look to see if the p-value is what? 0.05 or less. If the p-value is 0.05 or less, there's a significant difference between those 2 means. All right? Last time we did it when we were looking at what type of industry. We looked at industry, we looked at what type of industry, and we found that the means for particular industries were the same, but some were different from others. Manufacturing was different from, I don't remember. You have your file there? Yeah, she has her file. When we look on the significance, manufacturing was different from agriculture, and it was different from tourism. Okay, but as we came down the box, we didn't really see we didn't see any other differences, right? Okay. All right, and now when you want to see where those differences lie, you come down to box 3, and the box 3 will show you that manufacturing's mean is really 2.88, and it is statistically significantly different from 3.84 and 3.86. And you would then have to look back at the scale and figure out what those means really mean. Are they positive? Is that a high level of satisfaction or isn't it? Very dissatisfied in this case was a 1, right? Was a 1. So it would look to me that manufacturing's means were closer to the 1. So there was a higher level of dissatisfaction for persons who were working in manufacturing as compared to tourism and agriculture. But I mean, if you look at those means overall, the question is, where would you want the people to be? The highest mean there was about 3.86. For me, that is still not satisfaction because satisfaction would have been a 4. So overall, there's a problem, but there's a greater problem in manufacturing as compared to other industries. Y'all still following me with that? You still there? You folks at the back? You got that? Good. All right. With the independent samples t-test, you only really have to compare 2 means, so you don't have to run a post-hoc. The post-hoc that you ran there was Tukey. You had to run that Tukey because the Tukey then had to break down for you where the differences were in between the means because they had how many industries? They must have had about 6. So Tukey had to go in deeper and really show you, yes, there are significant differences in the means, all right, but where are those significant differences? And that's what the post-hoc tells you. All right, so whenever you're going to run these tests, I think that my SPSS handout gives you the commands fairly clearly. It tells you where to look. But if you are finding that you can't get the test run, look in Devanish's handout because he actually clicks and prints each screen. So you know exactly where you're supposed. He shows you the analyze, the descriptive. Go to Devanish's handout if you get stuck. But as opposed to what to do with each type of variable, this little SPSS handout should be okay. Now, all I want to do now is look at relationships between 2 linear variables. So far, we've looked at nominal by nominal and nominal by interval or ratio. But we haven't looked at ratio or interval by interval or ratio. Right? We haven't looked at that as yet. So far, we've only been limited by having one of our variables where we were looking for a relationship as being nominal. So I want to skip on to the next step now, where I will have two linear variables. Either those variables are ratio or interval. It doesn't matter whether it's ratio or interval. You do the same statistics with them. All right, so let's move on now. Linear relationships. Now, so far, we have only been able to identify the presence of a relationship. Is there a statistically significant relationship, for example, if we look at this data set, between gender and liking for the customer service? Are women liking the customer service significantly more than men? So we've only been able to say there's some relationship or there's no relationship between gender and customer service, or between income and liking the new payment plan. We've only been able to say a statistically significant relationship exists or it doesn't. Are y'all still with me? But when we are looking at linear variables, we get more power. Because we are not only able to look at the presence of a relationship where we check for the significance test or the p-value, we can look at the strength of the relationship and the direction. We can look at the strength of the relationship as well as the direction. Now let me give you an example. Say we are measuring, I don't know, number of discounts by number of repeat purchases. How are these two variables measured? Number of discounts that I give you by the number of times you repeat purchase. Both of these will be what types of variables? Nominal, ordinal, interval, or ratio. I agree, Lucia. They're real numbers. So suppose we had something like this. When I give you one discount, you give me two repeat purchases, one discount, two, one discount, three, one discount, 2, 6, 7, 8, 9, 10 discounts, 21, 25, 30, 35, 40. What pattern are we seeing here? That as the discounts increase, the number of repeat purchases going up. And really and truthfully, when we're talking about intervally scale questions or ratios questions, we're talking about variables on lumbar line, you know, we're talking about linear questions. Because I can put number of discounts here on the x-axis and number of repeat purchases here. All right, and as I see, 0, 1, the 6 down here, the 7, the 8, the 9. As I am giving you one discount, I'm getting what? 2, 4, and then we are here at 25 and 30. I'm seeing something like this. As I give you one, what? Who? 2 repeat purchases. I actually got 2 people here. And then when I'm giving you one, it's 3. And then when I'm giving you one, it's 2. So I got a lot of people at that point. And then when I'm giving you 6, it is something like what? 21. And when I'm giving you 7, it's something like 30. And 8 is 35. And 10 is 40. So I could run something like that through my points. Is linear. Y'all heard about the equation of a straight line? Y'all heard about least squares method in statistics? Y'all heard about the best fit line? That is what that is there. Because these are the actual points These are the actual points. And this is the best fit line that I would have run through to minimize. Why are you looking puzzled, Phillips? You did statistics? And that's the line you would have run through to minimize the errors between the actual predicted values of y, which should be on the line. These are the predicted values of y, and these are the actual values. All right? And really and truthfully, if I have something like this, where I have the x and I have the y, and I have points like this, look, that I can run my actual line through every one of the points. Those 2 points, right, have a perfect correlation. Because maybe every time I increase x by 1, I might be increasing y by 2. Or maybe every time I increase x by 1.5, I'm increasing y by 2. I can predict how when I make a change in x, the change I'm going to see in y. So this is a perfect correlation between x and y. It is plus 1 because it is going in a positive direction, because as x is increased, y is also increased. Y'all following me? So look, I know that a relationship between x and y is present. I can see it. I also know the strength of the relationship. They are perfectly correlated. And I also know the direction of the relationship. It is positive. So I can see that there's a significant relationship between x and y. That is clear to me. They're perfectly correlated. It is very strong. And I also know the direction. It is positive. Now watch this. If I had something like this, that would also be a perfect correlation. But the correlation coefficient would now be -1. Because as I reduce x by whatever, I can predict that y would what? As I reduce x or as I increase x? What am I doing there? As I increase x, y is doing what? Going down. So that is a perfectly negative relationship. Sometimes you have points like this, where you might have the x and the y, and you can maybe run your line through maybe about 80% of the points. Then there is an 80% correlation between x and y. So your correlation coefficient would be 0.8. If it was like this, and I could run maybe my thing maybe through 60% of the points, my correlation would be -0.60. This correlation would be stronger than that. But this correlation is not as strong as this. So I know the strength of the relationship. They move together about 80% of the time. I know the direction of the relationship. It is positive. Here, I know the strength of the relationship. They move together. I can predict what y would be if I knew x about 60% of the time. And I know that the direction of the relationship is negative. So the thing about when you are looking at linear variables, you can not only test one to prove that a significant relationship exists, and I will show you how to do that. You can prove how strong the relationship is. Are they 80% correlated? Are they 100% correlated? Because if I know, if I can see a pattern like this, every time when x is 1, y is 2. When x is 2, y is 3. When x is 3, y is 4. I know that every time I increase x by 1, I also increase y by 1. So I would know that if x was 209, y would be 210. I can predict because they're perfectly correlated. In that case, there's a perfect correlation. But sometimes the points don't line up like that. Sometimes I might find that when x is 1, y is 2, and then when x is 1, y was 1.5. These were actual statistics that I got from my sample, and sometimes when x is 1, and it will go back to y is 2 again. So this difference here makes that the correlation is not perfectly correlated. It might be 90% correlated, or it might be 80%. But those are still significant correlations. Are y'all following me? So the beauty of linear variables, because you can put them on a straight line, do a best, put the actual statistics that you got from the sample, and then run a best fit line through them, all right, you can actually predict, all right, what y would be or what x, if you know what x is. You looking puzzled, Phillips? You're puzzled? All right, so let's go back here now to the slide. For linear relationships, which is what I just showed you there, because they're on a continuum. Intervally scale questions are on a continuum from extremely important down to not important at all, or strongly disagree down to disagree, or in this case, very often down to never. Those are intervally scale questions, right? So they're on a continuum. They're on a line. All right, just as how many repeat purchases or how many discounts, those are ratio variables. They could go from 0 up to infinity. Those are also on the number line. So those also qualify as linear variables. So for linear variables, if you're looking at relationships between two linear variables, if you're looking at a linear variable on its own, you look at the mean and the standard deviation. But if you're looking for a relationship between two linear variables, you're looking for a correlation. All right? For linear relationships, we look for the presence, the strength, and the direction. But for nonlinear relationships, which is when you have a nominal question in the relationship, you can only look for presence, so it's not as strong. Are you following me? You following me down there, Jeremiah and Clara? All right? Now, a linear association or a correlation is measured by the correlation coefficient. You see this? This is the correlation coefficient here. Those are the correlation coefficients. All right? And that coefficient indicates not only the strength, because 80 is stronger than 60, it also indicates the direction. When I have a negative, I know that as I'm increasing x, y is decreasing. When I have a positive, I know that as I'm increasing x, y is also increasing. You got that? Good. All right, let's move on. Any questions there so far? So these are rules of thumb. The correlation can go, a perfect correlation is either plus or minus 1. Just like this, these two examples here. A perfect correlation is either plus 1 or minus 1. Perfect. You can almost know what y is going to be as soon as you know x. So if you have a correlation coefficient from 0 to 2, we say that is really none. 21 to 40, very weak. 41 to 60. 61 to 80, weak. 81 to 100, strong. Now, there's what I can tell you, right? That really applies to the natural sciences, in social sciences. Because human beings are so different. In marketing, we might accept a correlation of 21 to 40 as being quite good. In that every time X happens, Y happens about 40% of the time. We might accept that as being quite good because of the complexity of human nature. All right? But we will look now at SPSS and see what SPSS accepts as being good. All right? Y'all still following me? Good. Now, before we begin to look at the data set, I want to show you something. When you are running a correlation, you can have one or you can have another assumption. Y'all heard about one-tail test and two-tail test? Huh? Let's talk about the same repeat purchases and number of discounts. Remember what the null hypothesis will say? It will say what? That there is no relationship between the number of discounts you give people and the repeat purchases. So they're saying it don't matter if you give them 0 discounts or 100. It's not going to affect how often they come again and buy from you. Are you still following me? Now, so the null hypothesis will always be there is no relationship between repeat purchases and discounts. Now, if you are running a two-tailed test, your alternative hypothesis now that you are trying either to use to dispute that would be there is a significant relationship, or you might put in here correlation or even association. We also use the word association for correlation between repeat purchases and number of discounts. There is a significant relationship between repeat purchases and number of discounts. When I'm saying there's a significant relationship though, am I saying whether that relationship is going up or coming down? No. All I said is that there's a significant relationship, so you run a two-tailed test. A one-tailed test is more stringent than a two-tailed test. You know why? Because it has to go through 2 steps. It not only says that there's a significant relationship, but that the relationship is going in a specific direction. Alright? So with a two-tailed test, I would be saying there's a significant relationship. With a one-tailed test now, which will be more stringent before it actually gives me a significant p-value where it can reject the null hypothesis, will say there is a positive correlation or positive relationship or association between number of discounts and number of repeat purchases. So the system has to show there's a significant relationship and then also show that it is not negative, that it is positive. So a one-tailed test is more stringent. You got to go through more before you say, yeah, this thing exists. So you're not only saying there's an association, you have to know, let the system know, has to show you, you are right, it is positive. There is a positive association between these two. So it is even a negative association. So the one-tailed test is looking not only for a significant relationship, but that it is going in a different direction. Not in a different direction, in a specific direction. Are y'all still following me? Are y'all lost? It's going in a specific direction. So the one-tailed test is not only looking for the strength of the relationship, okay, it is looking that it is going in a specific direction. A two-tailed test, so it could go in any direction. Whether they are positively or negatively associated, there's a strong, significant relationship between them. If you run a one-tailed test, though, you say, I'm looking for it to go in a specific direction. So that is why it's one-tailed, because it could only go in one direction or in the next. Are you following me? So a one-tailed test is more stringent. So you run a two-tailed test if no direction is hypothesized. Or you run a one-tailed test if a direction is hypothesized. You look at the bottom of the output box to see if there's a note. I'll explain to you what is the note in a minute. This tells you whether the association between two variables is statistically significant. You can look at the bottom of the box to see if there's a note. You can also look in the box to see the p-value. All right? When you look in the box under Pearson's correlation, you see the p-value and they tell you how strong the correlation coefficient is. Also, when you look at that p-value, you will see whether, when you look at by the Pearson's correlation, the p-value will be right under it. You will see whether there's a negative sign there. If there's a negative sign, I know that there is a negative relationship. As x is going up, y is coming down. If I see a positive sign, I will know if x is going up, Y is going up as well. So y'all want to run some of these tests and see if you understand what I just said? Good. All right, let's look at these questions here now and identify for me some ratio and some interval questions that could actually go together. Age with what? Open up there for me. What about age with how many years you've been a client? Age with how many client accounts you have? Anything else? Is there anything else we could run there? Age with satisfaction, any of the satisfaction questions? Number of accounts you have with satisfaction? Am I making sense here? Are y'all lost? Are you lost? You're lost? Who's lost? Darling, there's a reason you're lost. You're lost because you haven't been here. Which was last week, right? That is the reason. Yeah. Who else is lost? All right. Where are the intervally? What are the intervally scale questions here? What are the intervally scale questions? Y'all know the intervally scale questions on this data set? The satisfaction questions. Where are the ratio questions? Number of branches. In the age or the age cat? Age. It can't be age cat. Age cat is a nominally scaled question. How many client accounts? The satisfaction questions. And so the satisfaction questions are what? They're interval. How many client accounts? What was that? Ratio. How many branches? Ratio. What about age? Ratio. So let's write that up on the board. Let's look at some of the possible questions that we can look at. We can look at the satisfaction questions by the satisfaction questions. I don't know if that makes any sense though. Those are interval by interval. We can look at the satisfaction questions by age. We can look at the satisfaction questions by number of years with business. We can look at the satisfaction questions by number of client accounts. We have a client account question. Okay. All right. We can look at age by number of client accounts. Do older people have more accounts than younger people? We can look at age by number of years with the business. As I get older, am I spending more time with the business, or do you find that there are a lot of young people that have been with the business a long time? So we see the correlations, possible correlations here with this data set. Let's now try and run a couple. Let's try and run satisfaction by satisfaction with customer service by number of years with the business. There's a question there called number of years that you've been with the business. That question exists? Yeah. Good. So let's try running satisfaction with customer service by number of years with the business. What are we asking here? Are persons who have been with the business longer more satisfied? Does satisfaction increase the more time you spend engaging with these people, or does satisfaction what? Go down? All right, so we are looking to see what is the relationship between satisfaction with customer service and number of years you spent with the business. So we're going to run the correlation now to see if there's some significant relationship between those two variables, or really and truthfully, satisfaction really has nothing to do with how long you've been with the business or how long you haven't been. In that case, we accept the null hypothesis. Why are you looking puzzled, Bradford? If there's, oh, because you would expect that the longer I'm with you, the more you should be satisfied? Yes, we would think so. Let's look at analyze. Let's just run a two-tailed test. Correlation by variate. Analyze, correlation, come down to correlation, correlate. And you run a bivariate correlation because it's between two variables. Click that there. All right? Let's run a two-tailed test, and we're running Pearson. So just put the two variables that you want over there. How satisfied are you with the customer service and your age. It cannot be age cap because that is nominal. How satisfied are you with the customer service and your age? All right? You got that? How satisfied are you with the customer service and your age? This is a correlation because you're looking at two linear variables. And what do you run? You click OK. Run two-tail. We're just looking for an association. We're not assuming a particular direction. First of all, there is no note at the bottom. Folks, there is no note at the bottom. And you know, when I look into the box, I realize why. What is the p-value? What is the significance to tail? 0.053. Is that significant? Why? What should it be? It should be 0.05 or less. It is what? 0.053. I'll show you something what the note says. If it was 0.05 or anywhere down to 0.0, say 0, I don't know, 199, it would have said significant at the 0.05 level. That is what the note would have said. However, if you had gotten a p-value of 0.001, it would have said significant at the, or less. It would have said significant at the 0.001 level. Work here with me. If you had seen that note, you would be 95% certain that there was a relationship between those two variables. If you had seen this note, you would be 99% or more certain that there is a statistically significant relationship between two variables. So if you had seen this note, you would have been 95% or more certain that there's a statistically significant relationship between two variables. So the note gives you an idea of what you're going to find when you look in the box. But when you look in the box and you look at the P, you will know what the significance is. Are you following me? So for the time you don't see the note at the bottom of the box, you know that when you look for that p-value inside there, it is not going to be statistically significant. What is the correlation between the two variables? Look by Pearson correlation. Age of client crossed by age of client must obviously be a perfect correlation. That is the same variable. But then when I look at age of client by how satisfied are you with our customer service department, where those two variables meet, what value are you seeing under there? Minus what? Minus 0.2. Watch this. Minus 0.2 is the correlation coefficient. Those two variables are associated about 20% of the time. And as what? Age goes, as age goes up, what's happening with satisfaction? It is coming down. it is coming down. So the significance to tail tells you the p-value, whether there's a statistically significant relationship. So there's no statistically significant relationship between those two because the correlation is too weak. Y'all got that? The p-value tells you if there is a statistically significant relationship. Because you do not get a p-value of 0.05 or less, it is 0.053, it is too large. You are accepting the null hypothesis. There's no statistically significant relationship. And when I look in the box at the Pearson correlation, it is only 0.2. It is a weak correlation. So the system is going to say those two variables don't move together enough of the time. That relationship is not statistically significant. Maybe if I had seen a correlation coefficient of maybe minus 0.4, the system might have said yes. There is a statistically significant relationship between those. They move together 40% of the time. And you might then get a p-value of, I don't know, 0.002. And that would be less than the 0.05. So first of all, the p-value or the note at the bottom. You don't even have to look for the note at the bottom. When you look for the significance to tail, that is going to tell you if there's a statistically significant correlation between the two variables. If it says there's a statistically significant correlation, you are interested in first the p-value. Is there a statistically significant correlation? P-value is the first thing you read. Or if you see a note at the bottom of the box, you ain't even got to look inside the box. There is a statistically significant correlation between two variables. Then, if it says to you that there's a statistically significant correlation, how strong is that correlation? In what direction is that correlation? Then you look by Pearson's correlation between the two variables. Obviously, if I do the correlation by age, and age is going to be 1. And if I do the correlation between how satisfied are you with how satisfied are you is also going to be 1. You cross the same variable, there's the same thing. They're going to be perfectly correlated. So you are looking by age, by how satisfied are you with the customer service, and I see a correlation of minus 0.2. Yes is in a negative direction, but they are not moving together enough for me to say that there's a significant correlation between the two. So this is what I would interpret as a marketer. Do not think that age has anything to do with satisfaction with customer service. The relationship is not strong enough for me to say that it exists. The p-value is too large. There's no note at the bottom of the box, and the p-value, when I look inside, it verifies it. It is too large. I have taken support there for the null hypothesis because the correlation is too weak for me to say that a significant relationship exists. Do you get that? Do you have that? So I start off by looking for the no or the p-value, and it must be 0.05 or less. And then I look at Pearson's correlation to see how strong or how weak the correlation is. And so hold on a minute. Let's go back here. The no at the box, on the bottom of the box, or the p-value tells me the presence. If a relationship is then present, I then look on the Pearson's correlation to see the strength and the direction. The two of these is the correlation coefficient. So the p-value tells me the presence, and then the correlation coefficient, which I read on the Pearson's correlation, tells me the strength and the direction. So don't look at strength and direction before you are sure that that correlation is a significant one and a significant relationship exists between those two linear variables. So we look for the p-verse or the note under the box. If you know that on the box folks, there ain't a significant relationship between the variables, there? There ain't no significant relationship. All right? So I want to skip from here now, where we can actually find a significant relationship, so that this would be reinforced a bit more. You see that handout that I gave you then eons ago? The first thing I gave you when I was teaching you SPSS, remember? Can you remember the handout that you entered the data from Bubbles? Look familiar? Look familiar? You don't have one of these? But you're going to have to share with somebody. Is there anybody who there's somebody who I didn't give one of these to? Anybody doesn't have one of these? So you could have, hold on a minute, you could have run correlations for all of those questions there. You could have run one time. And you could have run them one time. You don't have one of these? Okay. So we need to take this out now and turn to the second last page. Second last page. So hold it a minute. You understand how you would have run your correlations with this data set, right? You just pick out the intervals and the ratios and you cross them using the correlation coefficient. So we're going to go a little deeper now into this correlation regression business. Now you see that data that we have there? See that data that we have there? We have it in territory. So let's assume that this is, I don't know, let me see data before I give it a name. Let's call it that this is Xerox photocopiers. These Xerox photocopiers, they make and sell them. All right, let's look at this data. They have several what? Territories. So these will be several geographical offices. They have offices in several geographical locations. All right? Good. Offices in several geographical locations. And what else do we have here? We have number of sales in each territory. Second last page. Number of salespersons, and then number of sales. So we have here territory. Let me make sure everybody down here has it. In this case, I'll say my number of salespersons are my X and my number of sales are my Y. Hold on. Let's look at this. Correlations are a measure of associative analysis. How two variables move together. Just now when we were looking at repeat purchases by number of discounts, we were looking to see how number of discounts being the X move with repeat purchases the Y. They're moving together. Okay, so when I'm looking for X out here, can I find Y there? When I'm looking for X out here, can I find Y there? Are they perfectly correlated? Are they 80% correlated? Can I predict where Y would be 80% of the time when I know X? So is X and Y moving together? That is correlation. You know what regression says? It goes a step further. It doesn't only say that X and Y moves together. It says that X predicts Y. X causes Y to happen. So look, me and you could be moving together and we roll together, right? But it's you parents that cause you to happen, not me. We just move together. Regression says X and Y don't only move together. When I make a change in Y, a change in X, it causes a change in Y. So me and you can move together. That's all correlation saying we hang out together. Regression says we don't only move together, X causes a change in Y. You know, we will just talk about independent and dependent variables. This is what we're talking about, folks. When one thing brings about a change in the other. When the variance in Y can be explained by a change in X. So a correlation says association or moving together. Regression says not only association and moving together, but actually one variable causing the other to happen. All right, so this is very important for you as marketers, you know, because we got to understand forecasting. If I make a change in advertising, what change will it bring about in my sales? If I reduce my price by this percentage, what change will it bring about in my sales? This understanding of correlation, and especially regression, is a very important technique for you when you want to forecast sales. If I increase my sales promotion by this percentage, how much will it change my sales? All right? And that is what regression measures. It is what-if analysis. What if I increase my number of sales persons? How will it increase my sales? And the only way that you can do this regression analysis is if you have a set of data that you can then develop a regression line for. Now, go back to what I'm showing you. Say we had to predict, we had to plot these on the X and Y axis. What do you think here would cause the sales, the number of salespersons, right? And the variable that causes is always the X. And the variable that is caused is the Y. You know that from statistics, right? So the X here would be the number of salespersons, and the Y here would be the number of sales. All right? And we would have put down the sales and the salespersons for each territory. Actual variables that would have come from the data you have in front of you. And then when I run a line through it, that is my prediction. I actually take my actual variables, develop a regression line, and then I can use that regression line to predict the sales in any territory. Because remember, the equation of a straight line is y equals ax plus b, where a is the slope, this. Let me do it a bit different. And B, this is A, and B is the intercept where the line cuts the y axis. So A is the slope of that line that I would have run through all the actual points, and B is where the line that I used to predict my points cuts the y axis. So just work here with me. If I found out, for example, that A was 20 from this line, I'm talking about this line that I used to predict, and I found out that B was 6.2. Every time I know the number of salespersons, say found out I'm going in a new territory and my number of salespersons is 18, I should predict how much sales I could get, because Y then, which should be my number of sales, would be 20 the slope by the 18 salespersons I put in that territory plus the 6.2. So when I work out that equation, I should be able to predict if I put 18 persons in my new territory based on my line that I predicted from all of this data, I should get this amount of sales. So this line that you would have worked out, calling your regression line, where you try to minimize the distance between the actual values and there's the predicted line here, and these are the actual values, will actually work out to be a forecasting tool for you. And let's go through that now from start to finish, because I can say it again. That was just an introduction. Let's start over. So the first thing you have to do for me, folks, is enter all of that data that is in front of you. Open a new SPSS file. Type in territory. Y'all totally lost? Yeah? Well, that's fine. It's right to be totally lost right now. Type in territory, sales, and number of salespersons. And just type in that data because it is real data. You don't need to define any variables. You don't need to define any variables at all. Just type in territory. Y'all lost down here completely? Territory, sales. and number of salespeople. You don't have to define this variable because they're real numbers. So just type in territory, sales, number of salespeople, and just go to the data view and start typing in data. Just name them. Territory, sales, number of salespeople, and go straight to data view. It's real data, start entering them. It's real data. It's ratio data. Please name it though. Name it. Name them. You see here by label, put in the label. So put in territory by name and then put in territory by label. Put in sales by name and then sales by label. You don't have to define it. Are you lost on? You don't have to define it because it's real data. You just type in the real numbers. If it was interval though, you would have to define it. All right. Work. You see the commands there? Work with me here. Why? Just so you look in the ANOVA table to determine where the predictive relationship is, and we saw the p-value as 0.000, right? Then look to the model summary table to see what percentage of the variance is dependent. Hold on. I told you that R was the what? The correlation coefficient, and in this case, it is the same 0.941. You would have found that out if you had run the correlation on its own. See, you see the repeat the statistic. So the 0.941 says they move together 94% of the time. But you know what the regression is telling you? That R squared or 0.941 by 0.941 explains how much of the variance or change in Y sales is determined by the change in X, number of salespersons. So what is R squared? R squared is the variance. That is really the predictor. R is the correlation, the move. The R squared says how much of the change, not how they move together, that is R. R squared is the variance, and it says how much of the actual change in Y, number of sales, is explained by the change in X, number of salespeople. So what is 0.941 by 0.941? What is R squared? 0.88. So we're here, look at the front. So 88% of the change or the variance in number of sales can be predicted by the change in number of salespeople. So I would know that 80-something% of my sales then is explained by how much salespeople I got in any territory. So it tells me, folks, that the majority of whatever happens in any territory that I have depends on the number of salespeople I got in it. That is very important for you to understand as a marketer. Because if it was only 20% in variance, I would know, which would be the R squared, I would know that I need to explain 80% of what happens is happening in my territory with other variables that I might not know yet. You understand what I'm saying? This is a very, very, very important thing for a marketer. So I know that 88% of the change is explained by them. You see something called adjusted R squared in the model summary. All that adjusted R squared is what it would be if I had taken the data from an entire population and not from a sample. So that does make an adjustment for, that would look at the data and say, look, you only look at how much territories here, 21, but suppose you look at all the territories in the world, the R squared will still be high if it's still what, 80 what, 87%. Either way for me, that ain't much or muchness, 88, 87, folks, it high. It high. All right? Now, the standard error, the estimate, gives an estimation of how close the regression line is to the actual values. Now, you plotted some actual values for those territories. You would have put the number of salespeople, because the system, when you put in that data, When you put in that data in the system calculated a regression line for you. See what you have there in front of you? That is a regression line. Now, I can show you it in a minute. When you put the data in this SPSS, it would have put the salespersons on the X, and it would have put the sales on the Y. And it would have calculated a regression line. You see this? The third box. The fourth box. The fourth box is your regression line. The fourth box is your regression line. And look. Now we know you used to say y equals a mx plus c or y equals ax plus b. I'm going to call it y equals ax plus b. And I know that a is the slope and b, where the line, the predicted line cuts, the y-axis is the intercept. Now you would have put in the data for the 21 territories. I don't know, that might be territory 13, this might be territory 10, this might be territory 1, territory 4, territory 6, whatever. And that computer would have run a best fit line through those actual, see that actual data that you type in today? That computer would have run a best fit line through that data to minimize the errors. That's what we call it, the least squares. So then this line now is actually a model that could predict sales in any new territory that you have. Now let's look at what the model is. Come down into the fourth box. You see something there marked constant? Constant? That is the intercept. The constant is equal to the intercept. All right? So what is the intercept in this case? The B, 46.1. All right? The constant is the intercept. The number of salespersons, what you see, that 13.6. That is the slope. So 46.1 is the intercept, 13.6 is the slope. Watch me. Y is equal to AX plus B. Y, this is the regression equation here now. This is the equation of the regression line. Y is equal to 13.6x plus 46.1. Y, the predicted Y, is equal to 13.6x plus 46.1. So let's look at that over again. The real power in this is the predictor line. When you come down to the coefficients, the constant is the intercept of the predictor line, where it cuts the y-axis. That is 46.1. The number of salespersons is the slope. Okay? So that is your A. The A. The intercept will be the B, which is the 46.1, and the slope, but next to number of salespersons under unstandardized coefficients, is 13.6. Y'all still following me? Y'all got me? Good. So the actual predictor now is Y. This is what you want to predict is equal to AX plus B, where this is the intercept or the constant, and this is the slope, which is this. This is the actual line that you predicted there now, that slope. So Y is equal to 13.6x plus 46.1. Let me show you the beauty of this. How many territories we got there? 21, right? Suppose I wanted to open a new territory in Nebraska, and I decided that I would put in 19 salespeople. Suppose I want to open a new territory, number 22 in Nebraska, and I decided I want to put in 19 salespeople. Watch how this prediction will tell me how much sales they are supposed to give me if that data was for a year in a year. Y is sales equals 13.6 by X, which in this case is 19 that I'm putting in Nebraska plus 46.1. How much sales I should get from them 19 salespeople based on that line? Y'all understand what I just did there? I took the actual data, developed a regression model, which I could then predict for any new territory. If I put in this number, salespeople, how much sales I should get in that thing. Work it out there for me. Y equals 13.6 by 19 plus 46.1. 13.6. I ain't going to repeat it for you, darling, because you was busy doing something else. That's the thing about teaching in here with these computers. People are doing it with a link, and then his mama don't understand. 13.6x plus 96, 46.1. What you got there? 3 what? Right. So I should be getting, if it's $1,304 million in sales. If after the first year in Nebraska that 296, I coming down, saying wrong. Because if the conditions are right in Nebraska as it's been in everywhere else, where is my other $8 million in sales? Where is it? I have put 19 salespeople in there. My regression model has looked at my other 21 territories. That is the regression equation it has worked out. Y equals 13.6, X was 46.1. B is the constant based on that best fit line where I have minimized the errors. A is the slope. When I put 19 people in my territory, give me $304 million in sales or more, or I'm coming with my rod. Y'all understand what I'm saying there? Also, it goes the other way around. If I want to get $500 million in sales in a particular territory, then I got to work out how much sales people I got to put in. Capiche? All right? So if I want in territory number 23 to get $350 million in sales, 350 is equal to 13.6 by X plus 46.1. 350 minus 46.1 is equal to 13.6 by X. 350 minus 46.1 divided by 13.6 will tell me how much sales people I got to put in territory number 23 to get $350 million in sales. Do you get that? That is a very important tool for you. Because you might look at so many different changes as a marketer and then try to predict how much salespeople you need. Because the regression equation throughout all the remainder the variance that was due to something else. So it now tells you how you need to manipulate salespeople to get the sales that you want. There's something here called the standard error of the estimate. And it actually looks, your standard error of the estimate is what 8 something. It tells you how close this actual predicted line is to the Y values. So the smaller the standard error of the estimate, the better your model is. The smaller the standard error of the estimate, the better your model is. I won't get into all of that. You know, I just want you to know about regression. It is a forecasting tool. It is a very important forecasting tool for marketers. So you see that foolish line there? That is the model that you use to predict. Just that little foolish line there that you would have learned in statistics about best fit line. You remember they talk about best fit line and minimizing the error between the actual line that you predict and the actual Y values. Do you remember that? Or that don't sound familiar to you? Is there anybody who does not understand what I just did?